Hi everyone, this is Janine Ko, aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt to the situation quickly. That's why we are running free and daily classes for math and chemistry from grades 11 to first year college and university. For today's class, I will be going over the most popular questions that we receive on the One Class Homework Help platform. So, let's get started. So, let's just focus on math for now. So, this class will all be about math questions that we receive based on the most popular ones. So, first, well, here's the question, right? So it says, how much is 168 centimeters in feet and inches, right? So as you can see, if you recall, in order for you to convert feet into inches, it's basically, that 1 feet, right, or 1 foot is actually 12 inches, right? And on the other hand, you know that 1 inch is, or an inch is 2.54 centimeters. So we need to work our way backwards, right? So we have 168 centimeters, right? We need to convert this into inches first, and then from inches, we need to convert this into feet, right? So let's see what they said. I mean, I appreciate that they gave us this table of values here where we can actually find the measurements, right? But I think what I'm looking for is specifically how do we convert 1 foot into inches, right? Because 1 foot is actually 12 inches, and I don't really see any units here. Okay, yeah, it doesn't say any units here, so 1 foot is 12 inches. And then if we have an inch, that's 2.54 centimeters. So maybe if they can have a unit over here, like a title, just so we know which way we're going. Okay, but let's see what they wrote. So they're saying you have a centimeter, which is equal to 1 over 12 times 2.54 feet, and then you have 168 centimeters, which is equal to 168, and we're converting this to feet, right? So maybe we can illustrate that over here. Okay, so they're saying we need to convert 168. So we need to convert 168 centimeters into feet and inches, right? Okay, so we know that 1 foot is 12 inches, and then we know that an inch is basically 2.54 centimeters. So that's based on the table that they presented us. Again, I prefer if they would have shown us what the units are. And then, let's see. Okay, so now they're saying that we need to multiply, right, 12 times 2.54, right, to get to feet. And that's actually right. But again, I think I would love to see the units as opposed to just having 12 times 2.54, because this is all about unit analysis, right, or dimensional analysis, depending on your teacher. So you would really have 168 to begin with. So this is in centimeters. And then because by looking at the units that were given, we can actually say that because this is in centimeters, this would be 2.54 centimeters because you want to cancel out your units of centimeters. And then this is an inch, right? So if you want to convert this to feet, right, you would have inches over here. So we've used centimeters to inches, and then we would have to use 12 inches, and that's 1 foot, right? Does that make sense? So instead of having 1 over 12 times 2.54, I would better rewrite my equation into something like an inch over 2.54 centimeters, because I would like to illustrate that it's in centimeters, and then this is multiplied to 1 foot over 12 inches, because at the end of the day, I think when you're trying to learn this in class, right, in based on your teacher, they would actually like you to provide your solution. So you need to show your work. So that's why you need to have the units, right? Otherwise, you're going to lose your marks. Okay, so this is 168, right? And this is times 1 over 2.54. And this is times 12, right? So as you can see, this is 5.51. Yeah, this is about 5.51, and this is in feet, right? Okay, let's see what they wrote. Yeah, so they're saying that this is 5.512. Yes, it's right. So this is actually correct. Okay, so moving on to this, right? So this is 0.512 feet, right? And then they're just converting this into inches, right? So again, you can actually convert this 5.51. So because they had 3 digits after the decimal point, so let's just keep that as 5.512, and this is feet, right? So they wanted to convert this into, so we have this into inches, right? So as you can see, we have 1 foot. That's basically 12 inches, right? Let's see what they're trying to do. Yeah, they're trying to convert this into inches, right? So you have 0.51 feet, 512 feet. Okay, so I don't really see a point of converting this into inches because first of all, the 0.512, they're not really asking you to convert this into inches, right? Because it just goes back to the question, right? It says how much 168 centimeters is in feet and inches, right? So essentially, you don't want to convert this feet, amount of feet into inches, right? Because the whole point of this question is to start from 168 centimeters and you want to convert this into inches. So in my opinion, I would actually start from 168 centimeters and just convert that into the following units, right? So I wouldn't even look at this, right? So, okay, so the best way to go and look for your units, right? So now we've found feet, right? So that means we're now looking into inches. So in that case, you would start base from your given, right? This is the rule in chemistry, in physics, any science that you need to do calculations. So you need to start with your given, right? 168 centimeters, and then you need to assess which is your endpoint, right? Because we found what this in feet is, right? Now we just have to go into inches. So we know that we need to have 2.54 centimeters. So that's going to be in your denominator, and then this is 1 inch, right? And you can cancel your units, and that's it, right? Simple as that. I don't really know why they had 0.512 feet to begin with, but this is the most straightforward way to go. So you would have 168 times 1 over 2.54. So this is actually 66.142. So this is in inches. Yeah, 66.142. So let's keep 3 digits after this, the decimal point. So you would have 66.142, and this is in inches. Okay, so let's maybe see. And by the way, this is approximately because I had to round things. Okay, so what I'm getting right now is 66.1, right? 142. So this is actually incorrect. It's not supposed to be 6.1 inches. So, okay, so this is their final answer. So they're saying in 168 centimeters, there are 5 feet and 6 inches approximately. Okay, so I would just go back to 168 centimeters, right? And say this dimension. So this dimension, 168 centimeters, is in this feet, and you have 168 centimeters, this in inches, right? Unless they ask you differently, which was, let's see. Yeah, because the way you're going to interpret this question, it could be two ways. The first way would be to separate 168 centimeters and convert that to feet, right? And then 168 centimeters, convert that into inches. Or what they mean is you need to express 168 centimeters in terms of feet and inches together, right? So if it's together, then they would have to use 0.512, which is right. Yeah, I think it's just a question, the way it's worded. I think it's very confusing because you can think two ways, right? So, but if they were looking at this together, then yes, you can take 0.512 feet, right? And then you would have to convert this into inches, right? Because technically, if you're thinking about a person's height, right? When somebody says you're 5'6", right? You would say that this is approximately 168 centimeters, right? And I think that's what they're trying to deliver. But if that's the case, you're combining the two, right? Because feet and inches are two different units, right? Which makes it confusing. So you can actually use that as well if that's how you're going to interpret this question. So you would have 0.512 feet and convert that into inches, because this is basically your decimal numbers, right? So you would have to convert that into inches, and then you would just say this is 5, right? So it's 5 foot, and this is basically 6 inches. Does that make sense? So yeah, this question, the way they answered it is right if you're combining the two. Because when you read it for the first time, it seems like they wanted you to find 168 centimeters in terms of feet alone and in just inches. Okay, great. So let's see. So let's just make a comment. So this is just my own comment. Okay. So we can actually say that this question, so this question, right? So this question, how much is 168 centimeters in feet and inches, can be interpreted in two ways, right? In two ways. So it's either the first one, which I thought, looking for 168 centimeters in terms of feet and inches, which means it's two different units. Looking for 168 centimeters in terms of feet independently of inches, right? Or vice versa. And then on the other hand, we can actually say that you can assess this question based on combining the two units of feet and inches as an entity, right? i.e., right, looking for a person's height. In terms of feet and inches. Okay, great. So that's my comment, right? There's two ways you can interpret this question. Looking for 168 centimeters in terms of feet independently of inches as a unit, or vice versa, right? As a unit. On the other hand, you can assess this question based on combining the two units of feet and inches as an entity, right? Looking for a person's height in terms of feet and inches together. Okay, great. Solution is correct. Great. So we finished that question. Okay, so now let's look at this question. How do you evaluate the ln of 5, right? Okay, so when you're trying to evaluate ln of 5, right? And they're saying that ln of 5 is a natural log on the base e, that's right, which is log e5, right? Because it's a natural log. And then it says the value of ln 5 can be calculated using the powers over e. Okay, so I mean, this is right. So this is e. So they're pretty much giving you examples, right? Like let's say if you have e raised to the power of 0, that's equal to 1, right? And all of this, you can actually obtain these values over here by punching them into your calculator. So make sure you have your e and you have your exponent 0, 0 0.5, 1. So they're just showing you what the values could be, right? If you have 0 0.5, 1, 1.52, and so on and so forth, right? And these are your y values. And then now, if you have ln 5 as x, in that case, you would have x is equal to ln of 5, right? Because you know that ln, which is the natural log, right, can be written as log e, right, with the base e, then you have 5 over here. The reason why they have this e raised to the power of x is because this over here, this log of e, to get rid of that, you need to raise both sides with e. Does that make sense, to get rid of log e? Because if you recall your logarithm based rules, right? So if you have, let's say, yes, so for log, basically they're saying you have x, which is equal to log e5, right? That's what they're trying to say. Yeah, so if you have x, which is equal to log e5, right? In order for you to get rid of this, you would have to express this and this, right? You need to raise both to the power of e, right? Does that make sense? I think it would be better if they actually show you this step, because I think it's easier for students to see that if you're raising both with e, right? And as you can see, this thing over here is actually equal to 1. So this would give you just 1, right? And according to logarithmic rules, right, because this has the same base as this, you can actually bring down the 5. And hence, you're seeing that this is now e raised to the power of x, and this is equal to 5. Because the rule here is we know that this is 1, so you bring down the 5. 5 times 1 would give you 5. So that's why it's e raised to the power of x, which is equal to 5. Okay, so let's go back to this question. So this is right. Now, let's see. Yeah, the only way for you to find what the exact value of ln 5 is, which is 1.61, is, let's see, because right now they're trying to approximate, right? But I think at the high school level and also in the university level, if you're just taking like general calculus courses, you don't need to approximate in order to find what the value of ln 5 is, because I mean, you have your calculator, right? So you can just type in ln of 5, right, and find that if you have ln of 5, which is equal to 161, because you're not proving anything, right? You're not proving that ln 5 is equal to 161, right? If you need to prove, then you approximate. So I think for this question, we can even stop here. We don't even need step 2. Right? We don't even need step 4 because we don't need to show that it's 1.61, 1.62, and so on and so forth. I think the only time that they're saying that this is approximately 5 is because if you look at 1.62, right? This is just a way to check, right? If you have 1.62, you're going to see that this is 5.05, which makes it 5.1. So it's not really precisely 5. And when you have e raised to the power of 1.61, you're going to see that this is actually 5.0, right? So you can actually say that this over here must be equal to 161 for this to become 5. Does that make sense? Because if you remember, right, how do you find, let's say this, right? Ex is equal to 5. Well, we know that this is log e, right? So recall back to your exponential function and your logarithmic function. So if you have ay, which is equal to x, right? So this is your exponential function. That means you can actually rewrite this, right? If you need to solve for this logarithmic function, you can rewrite this based on your exponential function, which is log a x, right? So if you're seeing that your a is e, right, you can actually say that this is going to be e, and then you have just y because your y is this, right? And what else? Actually, your y in this case is going to be your x, right? Over here. And then, actually, let's move this here. Okay, I guess there's no space. But what I'm trying to say is, in order for you to calculate how this came about, right? How did you know it was 1.61? Well, all you have to do is set this up into an exponential function, right? And then you're going to rearrange this such that you know that this is going to be, let's see. Okay, so your a is e, right? And then basically you have your y value, right? So remember what we said what y was. So y is basically 1.61, right? So this is 1.61, and then you have your x, which is log e of 5, right? So that's going to be over here. Does that make sense? Because x is equal to log e of 5, therefore we're going to say that e, then you have 1.61, which is equal to log e of 5. Okay, so yeah, this is right. I don't think anything has to be said except for showing this step, right? So maybe that's called showing an extra step for consider ln 5 as x, that part. Okay, so let's write a comment. Okay, so the solution and answers. So the solutions and the answer provided are correct. However, I wouldn't say an additional step, right? Because they can probably omit that just by looking at this. But I think if you're learning this for the first time, you would want to see that your exponent is being brought down. And that's this part, right? Yeah, it's right here. So maybe we can say, but show e raised to the power of x. So e raised to the power of x is equal to e, right, raised to the power of log, and this is basically base of e, and then you have, yeah, this is supposed to be base, and unfortunately we don't have that function to turn this into e, and then basically this is times 5, right? Why is this autocorrect? Okay, e, okay, what did I say? E raised to the power of log e, and then you have times 5, right? So multiply to 5. And then let's put this in a bracket, in a larger bracket. There we go. Okay. Please show this is equal to e raised to the power of x is equal to just 5. Okay, great. So solution is correct. Okay, great. So let's move on to the next question. It says, which equation represents the graph function? Okay, so they're telling you that you have 0, 3 as your y-intercept, and then you have another coordinate, which is at 3, 2, right? So first of all, how do we find which equation will represent our function? Well, we know that it's supposed to be a negative slope, right? So that's why, because we have the slope-intercept form presented, then we can actually root out the things that, or I guess the options that we shouldn't be looking at. So because it's a negative slope, therefore we need to compare B or D. Does that make sense? Because we know that here you have a slope of +3, right? And here for part C, you have a slope of +3. So you don't really want that, because you know that it's a positive slope. And just by looking at your graph, you know that this is a negative slope. Okay, so let's see. Which equation represents the graph function? Okay, because you have 0, 3 and 3, 2, you can actually find what the slope is based from these two. So 0, 3 and 3, 2. So let's write that. So if you have 0, 3 and 3, 2, right? So just by looking at this, you can find what the slope is, right? If you recall, we have this y2 minus y1 over x2 minus x1, right? So we know what x1 is, we know what y1 is, we also know what x2 is, and we also know what y2 is. So y2 is 2, right? And as you can see, this formula has the negative sign, so make sure that if you have a negative coordinate, just distribute that. So you have negative, and then you have y1, which is 3, and then your x2 is 3, right? Then your x1 is 0. Okay, great. So there we go. So we have 2 minus 3, which is equal to -1. And underneath this is basically 3 minus 0, which is equal to 3. So as you can see, we have m is equal to -1 over 3, right? So that's our slope, right? So if we have that as our slope, and also on top of that, we know that we have a y-intercept, right? So this is our y-intercept because it's 0, 3. So we know that our b value must be equal to 3. Does that make sense? Because we're looking for the slope-intercept form, since those are the options that were provided to us. So in that case, you would have y, which is equal to -1 over 3x, and this is +3. And we're not yet done, because as you can see, the options that they provided us, everything is in terms of a whole number, which are not in fractions. So yeah, let's go back to this. Yeah, everything here, as you can see, they're all in terms of whole numbers, right? Like B and D, for example, which are the options we're kind of choosing, right? There's no fractions in here, right? So that means for this, right, we need to turn this into a whole number equation, right? So if you have this 3 over here, for this to become a whole number, you need to multiply your entire equation by 3, right, to eliminate this denominator. So you would have 3y, which is equal to -x, and this is basically +9. Does that make sense? So when you kind of rearrange this, you're going to get -x, right, minus 3y, which is equal to 9. I mean, it's pretty much 3y is equal to -x plus 9. If you try to move this to the opposite side, this 3y, it becomes -3y. Or maybe we can actually change this -x and turn that into a positive x. So if we move this -x to the opposite side, we get x plus 3y, which is equal to 9, right? So regardless, we don't have that option, right? Okay, let's go back to the question. Yeah, we don't have that option. So apparently there is... Yeah, so apparently, as you can see, it's not within the following options. But I guess this is the solution, right? So let's see what they're saying. So you have y2 minus y1, x2 minus x1, and that's right, the slope is -1 over 3. You have a y-intercept at 3, therefore its y is equal to -1 over 3x plus 3. Hence, option D is the only answer. No, this is not the answer. This is -13. It's supposed to be -1 over 3. I guess they have a typo, but it's not D. Definitely it's not D, because it's -13x the way they're presenting that. So maybe we can make a comment. Okay, so here's what we're going to say. Options A to D or actually, the answer is not provided in options A to D. So the answer is not provided in options A to D. The answer is negative 1 over 3x plus 3, which is equal to y. So negative 1 over 3, and this is x plus 3. So that's the answer. However, the solutions that they provided is correct, or explanation. Okay, let me just... Okay, for some reason, I don't know what happened. Give you 1 second. Okay, great. So the answer is not provided in options A to D. The answer is negative. So y is equal to negative 1 over 3x, and this is plus, we said it was plus 3. Okay, so second point is basically, however, the explanation that was provided is correct. Specifically, slope is equal to negative 1 over 3, and y-intercept is equal to 3. Okay, great. Solution is correct. That's right. Okay, so it says if f of x is a third degree polynomial function, how many distinct complex roots are possible? Okay, so let's read what they're trying to say. So it says, given that f of x is a polynomial of third degree and we need to find the distinct complex roots of it, an expression of the form axn plus an minus 1 xn minus 1 plus a1x plus a naught, where ai's belong to a real number for 0, so I between 0 to n, is called a polynomial. So this is right. And we know that the complex root of such a polynomial expression always occurs in pairs. That means the roots are complex conjugates of each other. If a plus ib is a root, then a minus ib will also be a root of it. So this is right. Two cases are possible. All the roots are real, then there are no complex roots. The second point being there are exactly two distinct complex roots, hence the answer is either 0 or 2. Okay, so because this question is very I mean, it's not really a skill question. They're not testing you to look at a third degree polynomial function and trying to identify what the distinct complex roots are from that polynomial function, right? So this is very it's just asking you a general question, right? So when they mean that two cases are possible, which is right, so say for example all the roots are real, then there are no complex roots, meaning you can't really factor, you don't have any zeros. That's what they're trying to say. You don't have any zeros. It's basically x cubed, right? So on and so forth. There's no factor, right? That's when they're trying to say there are no complex roots. The second point being there are exactly two distinct complex roots. So in that case, you would have... So this is just me giving you an example just to further illustrate that, because it's very it's a very general question. So when they're trying to allude to the second point, let's say you have x minus 5, right? And then this is basically multiplied to x squared plus 4, right? So as you can see, going back to the question, there are exactly two distinct complex roots, right? Therefore, this is going to be x minus 5 and x squared plus 4, because this is a root, right? And this one you can't really further simplify, right? There's no way you can simplify x squared plus 4, so that there's two roots. And then if you have an imaginary number, which I think they also brought up, It says, and we know that the complex root of such polynomial expression always occurs in pairs. That means the roots are complex conjugates of each other, and then so on and so forth. They presented a plus bi is a root, then you have a minus bi will also be a root of it. So when they're trying to say that, right, you can actually expand this and say, okay, you have x minus 5, and then basically this is going to be x minus 2i. So the only way for you to factor this is to have imaginary numbers. So x minus 2i, and this is basically x plus 2i, right? So this is the conjugates, right, of each other because it's minus and this is plus. That's what they mean by conjugates. Okay, so let's go back to the question again. Yeah, so it's right. I don't have anything to say. They pretty much answered the question, but give examples, I would say. So let's see. So the solutions and the answer is right. However, since this is a very general question, providing an example for the two cases will be appreciated. And, okay, no, not will be appreciated, will be easily understood. Yeah, that's what I wanted to say. Seen and understood. Okay, great. Solution is correct. Okay, so let's go to this question. How many sides does a regular nonagon have? Okay, first of all, before we even get into polygons, I just wanted to ask you guys, basically, if you know all of your prefixes, right? So if it's non, right, because it's a polygon, right? So you have this prefix nona or non. It's basically 9, right? So n is equal to 9, which is right here, right? So you have to know your prefixes, right, by now. So you have quadrilaterals, pentagons, hexagon, hepta, octa, and then you have nona, and this is deca, right? 10 means deca. So in that case, that's why it's called a nonagon, and it's only 9 sides. And let's see. Because they're only asking you how many sides, it's pretty much just 9, right? And that's it. So yeah, it's right. And then I just wanted to correct something because I did notice this. The sum of the interior angles, although this question, if you look at this, is not even related to this main question over here, then in this case, I just wanted to correct this because this is actually wrong. The sum of interior angles is supposed to be n minus 2, not n times 2. So I guess this is a typo. So yeah, it would change completely everything, right, if you have n times 2. So this should be n minus 2 times 180. So this is the sum of interior angles of polygons, right? So that's just a correction. Okay, so the solutions and the answer provided are correct. However, when they, what is the measurement of each angle in a regular polygon? Okay, however, the sum of interior angles, actually, the formula of the sum of interior angles is supposed to be n times 2, right? So n, or let's just keep it as 2n, right? Sorry, so this is not n times 2, so this is supposed to be n minus 2 times 180. So 180 times n minus 2. Not 180 times n minus 2, so that's supposed to be the sum of the interior angles, and not what they have presented. Okay, solution is correct. Okay, great. So let's move on to this question. Which expression is equivalent to assume? So we have this, right? So first of all, because we have exponents that we need to deal with, I think it's easier if we try to write this down. So we have 2, 7, 3, and 5. So it's basically x and y. So we have x raised to the power of 2 over 7, right? So anytime, so if you're learning algebra for the first time, anytime you're seeing, this is what you call a radical expression, and you have, I think it was y and 3 and 5. Yeah, anytime you see a radical expression, so let's say you're looking at this over here, so just focus on your numerator. Don't get overwhelmed just by looking at the fraction. So anytime you have a radical expression, that means whatever is inside your root, that would be your numerator. So a radical expression would have an exponent that is in the form of a fraction. So if you're looking at x, right, alone, that means your exponent would be whatever is inside, and that's 2, right? And your root would simply be your denominator. So that's going to be over 7. And then this is all over because of this division symbol, and this is all over y, and whatever is inside your root, because this is cube, right? Therefore, this is going to be your exponent, right? And that's specifically your numerator. On the other hand, your denominator would simply be 5. So let's take a look of what they wrote. And by the way, I just wanted to clarify, if your y expression is in the form of an x, right, then you can simplify this further, right? Because these two are not like terms, therefore this is your final answer. So yeah, let's see what they wrote. So x is 2 over 7 and 3 over 5. Yeah, this is right. So this is a perfect solution. And the only reason why I like this setup is because it's very straightforward. They didn't try to go in different directions. So I appreciate that it's pretty direct and straight to the point. So perfect solution and answer. That's it. Solution is correct. Great. So let's move on to this question. It says 5.21 centimeters is the same distance as the following. Okay, so they're solving this in order. Okay, so what we can do, we can solve this first, and then we can compare our answers based from what they've shown us, right? So let's take a look. I'm just gonna make this smaller so we have enough room to. Okay, great. So they're saying 5.21 centimeters, right? That's your given. So let's start with our given. So we have 5.21 centimeters, and we need to compare this and show our answer in terms of kilometers, meters, and yeah, so kilometers, meters, millimeters, and decimeters. If you recall my mnemonic, I'm not sure if you attended my class for the Q&A math a couple of days ago. So basically, I brought up this mnemonic, which is King Henry died drinking chocolate milk. Okay, I don't think this is gonna fit, so let's kind of move this. Yeah, so I brought up this mnemonic for you to easily remember how you're supposed to move your decimal point, or what are you supposed to do. Is it multiplication or division in terms of this mnemonic, right? So because this is in centimeters, right? So we know that C stands for centimeters. This one is in millimeters because it's M. And then we have D, which is basically decimeters, right? Oh, and also we forgot something. We forgot unexpectedly. So that's going to be, let me make this smaller if we can fit everything together in just one row. So we forgot unexpectedly. Okay, great. So once we've have everything here, so this is in millimeters, this is centimeters, this is basically decimeters, right? So dm, and it's smaller case d, right? And then this is your unit, which is in meters, and then you have capital D, which is deca, right? So this is decameters, so capital DM, and this is hectometers. This is kilometers, right? So as you can see, because you're currently at 5.21 centimeters, then how do you convert centimeters to kilometers, right? So all you have to do is move to the left, right? So what does it mean when we're trying to move to the left, right? Our unit becomes larger, right? So now it's kilometers. Therefore, our number must become smaller. So if you have 5.21 centimeters, because you need to move from this point to this point, so 1, 2, then you have 3, 4, 5, right? So you need to move your decimal point 5 times, right, to the left. And why is it to the left? Because you're starting from centimeters, which is a smaller unit, right? So in that case, it's 5, right? So 5.21. So 1, 2, 3, 4, 5. And then you mark this over here. So in that case, this would be 0, right? 0, 0, 0. Anytime you don't have anything right here, you're going to place a 0, right? So in that case, from centimeters, from 5.21 centimeters, this is actually 0.0000521, and this is now in kilometers. So this is your final answer. So let's compare what they wrote. So they're saying that option A is false. That's true. And why is that? Well, if you're converting 5.21 centimeters, this should be how many zeros did they had? So this is 1, 2, 3, 4. So they had 4 zeros, and we had 4 zeros too. So this is right. And they're trying to say that for every 1 kilometer, that's 1,000 meters, and then you have another 100 centimeters because we know that for every 1 meter, that's 100 centimeters. So this is right as well. Okay. I just like this method because I think it's just easier for you to remember as opposed to remembering, okay, 1 kilometer is 1,000 meters, so on and so forth, right? Yeah. The way I learn, and probably the majority of my students, if you're listening right now, again, it depends on how you learn, right? If you like to process information and kind of store them based on this, right, then just go ahead and use that. Or if you want to store the information based on, okay, 1 kilometer is 1,000 meters. The only reason why I prefer this over this is because it just reduces the amount of information that I can remember, right? So yeah, I like to draw patterns and remember things that way. Yeah, because sorry, and also I just wanted to mention because I do know that there are some students who just have a hard time memorizing numbers, right? So that's why I'm presenting two ways. Okay, so let's move on to meters. Okay, so as you mentioned, sorry, as this person mentioned, they're saying that 1 meter is 100 centimeters, right? So if you have from centimeters, you're going to meters, then all you have to do, right, is, so if you have 5.21 to begin with, so you would have to move twice, right? That's why you're dividing by 100, right? From centimeters to meters, you're dividing 5.21 with 100 because you're moving to the left, right? That's why it's division. And on top of that, you're moving twice, right? 1, 2, and that's why there's 2 zeros. That's why it's specifically 100. So 1, 2, and then you mark this point. If you don't have any number, you need to add a zero, because otherwise, if you don't add a zero, then it doesn't really change the fact that you're moving your decimal point. So that's why this must be 0.0521 meters. So yeah, for part B, it's still incorrect because the right answer is 0.0521 meters. Okay, so for millimeters, right, because we know that centimeters is right beside millimeters and all we have to do is move to the right once, that means we just have to multiply 5.21 centimeters times 10, right? So in that case, if you want to move the decimal point to the right once, you're welcome to do that as well, right? So 5.21, that means you move this to the right. Make sure you mark that point. Therefore, we know that this is centimeters. So this is 52.1 millimeters. So this is your final answer. So let's see what they wrote. This is still incorrect, right? So for C, they're saying it's 521 millimeters. So this is still incorrect. So for part C, they're saying 52.1 millimeters is right. So yeah, option C is still incorrect. Okay, now let's move on to decimeters. So for decimeters, we know that we're starting at centimeters, and all we have to do is divide 5.21 with 10. Why are we dividing? Because we're moving to the left, right? From centimeters, we want to move towards decimeters. And the number that we need is just 10 because we're moving once. Therefore, it's only 1 0, right? Does that make sense? So if you have 5.21, when you move this to the left, right, once, so it would be 0.521, right? And this is decimeters, which they have right here, 0.521 decimeters. So option D is in fact right. So decimeters is 0.521. Because we originally had 5.21 centimeters, so moving this to the left, right, once, right, would give you 0.521 decimeters. So option D is right. Okay. Yeah, so what they've presented, the solutions in the answer are correct. However, for some students that it's just hard for them to remember numbers, right? I mean, even I do, right? I don't like remembering numbers. I like to remember patterns and draw like what I can from them. Or, sorry, draw information from this information, right? Yeah, your preference, at the end of the day, you want to arrive at the right answer. So the solutions and the answer provided are correct. Okay, I would say suggestion for students. Yeah, for students who wish to use and also I just wanted to I guess mention that this mnemonic, it could vary depending on who your teacher. You can probably use a different mnemonic. It doesn't have to be King Henry unexpectedly died drinking chocolate milk. Does that make sense? So it doesn't have to be the same one, right? As long as it's something that matches what we have, right? That's fine too. For students who wish to use King Henry unexpectedly died drinking chocolate milk, to remember converting kilometers let's just abbreviate this. Kilometers, hectometers, units. Actually, let's keep this as meters. And then we have, so we have hectometers, then we have decameters, meters, then let's see. So we had the U, then we have decimeters. So we have decimeters, and so King Henry died unexpectedly. Okay, now it's right. Kilometers, hectometers, decameters, meters, decimeters, then centimeters, and millimeters, respectively. In order. Let's just keep it as in order. Okay, great. So solution is correct, and I think I've mentioned everything that I wanted to say. Okay, great. Okay, so for the last question for today's class, I just wanted to go over functions, right? How do you know if a function has an inverse function? So just by looking at b of x, right, this is supposed to be x squared. I don't think they have that option to turn this into a superscript, right? So this is x squared plus 3. Then you have d of x, which is equal to -9, m of x, which is equal to -7x. And finally, you have p of x, which is equal to x. Okay, so first of all, let me just quickly show you how each of the function would be graphed based on just looking at the function. So we know that for b of x, right, it's a parabola, right? Because it's a quadratic function. So x squared plus 3. So in that case, you would have this over here. So this is 3. So you're translating 3 units up, right? That's what the plus 3 is for. And then you're pointing upwards or opening upwards because you have a positive leading coefficient because it's positive x squared. So that means if you're looking at your function, right? First of all, do you know that this is a function? Yes. Why is it a function? Because we apply this vertical line test, right? So for you to identify first, right? So before we get into inverse functions, I just wanted to make sure you understand how this vertical line test works, and also the horizontal line test, which is coming up later on. For the vertical line test, right, if you draw your function, right, and you use what you call this vertical line, right, anywhere in your function, right, your function needs to pass through this vertical line once and only once, right? Once it passes this vertical line twice, then it's not a function. So for this to become a function, when you draw a vertical line anywhere, right, in your domain, right, in your function, it needs to intersect this vertical line only once. That's it. So that's how you know this is a function, right? So supposedly you wanted to know whether you have an inverse function, right? Because what they're trying to propose is you have this horizontal line test and then it's a one-to-one function, blah, blah, blah. So this horizontal line test is basically you find the inverse. So that's how you're going to solve for this. So you find the inverse. So how do we find the inverse of a function? So you have b of x, right, which is equal to x squared plus 3, right? So let's say you go and, switch up your y and x, right? But there's no point in doing that because you can actually apply what you call this horizontal line test. So this horizontal line test is literally you have your function, right? Draw a horizontal line, right? As you can see, your function passes through the horizontal line twice, right? If it does that, that means you don't have any inverse. Does that make sense? So If you look at this, right, if you have a horizontal line test, it passes through twice, right? That means if you, let's see what they're trying to say. Okay, so I guess this is for this part right here. Okay, so it says the graph of this function is a parabola, that's right. Each vertical line crosses it at exactly one point, which we've illustrated. And for the other one, it says, but horizontal lines can cross it at 2 points, which we've also seen. That means this can be a one-to-one function. So when they're saying that it's not a one-to-one function, therefore you don't have an inverse, right? So that's why this is really important, because you don't have to go and look for your inverse function. That's why this horizontal line test is important. And it actually saves you time, right? To go and look for your inverse. Okay, great. So I hope you understand the difference between the vertical line test and the horizontal line test by now, so we can move on to the other questions. Okay, so as you can see, d of x is basically -9 because it's a constant. I mean, it's not a function, right? It's just literally y is equal to -9. It's a horizontal line, right? If you have d of x, which is equal to -9, it's just a horizontal line. So -9 over here. So this is how your line looks like. It's not a function. Therefore, you can't really have any inverse function if it's not a function to begin with. So, yeah, and also the vertical line crosses it at infinitely many points. Okay, great. So let's move on to m of x. So m of x, you have -7x, right? So as you can see, this is a linear function, right? So -7x looks something like this. Yeah, it's supposed to pass the origin, right? Okay, there we go. So yeah, this is -7x, and they're saying that, so it is a function and also it has an inverse. Okay, great. So if you have the vertical line test, right? So, okay, this is supposed to be a vertical line, so we don't need the arrows. Okay, great. So vertical line test, right? That means it's only going to pass your function once, right? And when it passes this function once, it's exactly in a unique point, right? It's only one x and only one y. You cannot have infinitely many y points, right? Or x points in this case, right? So in that case, this passes the vertical line test, therefore this is a function. Now if you draw the horizontal line right over here, it means that it's also the same way as the vertical line test. It only passes that specific point, right, once, right? And it's a unique point. Like, it's never going to be the exact same point that you're passing, unlike when we were looking at d of x, which is equal to -9. Because for here, if you try to have so many vertical lines over here, you can see that yes, it does passes this line once, but the problem here is it's always going to be the exact same y value, which is equal to -9, right? So say, for example, you're at x is equal to -5, right? Your y would always be equal to -9 if you pass, like, let's say here. If this was x is equal to 1, your value would always be equal to -9. So you don't really want that, right? So it does not satisfy the vertical line test in that sense. So if you're looking at this, because it passes both the vertical line test and the horizontal line test, that means there is an inverse function, and on top of that, this is a function. So now you're probably wondering, so what's the inverse, right? So in order for you to find the inverse, you know that this is y is equal to -7x. Then all you have to do is switch your y into an x, and you have this x being your y. So you would have -7y. Now all you have to do is isolate y as you would in any function, right? So this is divided by -7 divided by -7. Therefore, your y value, or your inverse function, is y is equal to -1/7x. That's your inverse function. So you need to check your vertical line test first, then your horizontal line test first, and go and find your inverse. So that's the order. Okay, great. So p of x is equal to the absolute value of x. So we know that an absolute value is a function, right? So if you have p of x, so it looks something like this, right? So it has a vertex at 0, comma 0, it crosses the origin. So it is a function, right? Because at any point, right, wherever you're drawing your vertical line, it's a unique point, right? It only passes your function once and only once, and you're not having like infinitely many points as we would expect when d of x was equal to -9 from the earlier question that we've been doing, right? However, if you try to draw horizontal lines, right, at any point when you're looking at an absolute value function, well, it's passing through your function twice, so it does not satisfy. So yeah, can you see this? So it passes this line twice. So that means it does not satisfy the horizontal line test. Therefore, you don't have any inverse for p of x, which is equal to the absolute value of x. Okay, great. So yeah, I guess the explanation that they're saying so far by looking at it, they're all right. Inverse function. By the way, the only time that they brought up one-to-one function, it means for every x value that you're getting, you're going to have a unique y value. So that's what they were trying to say. So that's what one-to-one means. Okay, so yeah, I don't have anything to correct from here. So perfect solution and answer. Okay, that's it. Okay, great. So, before I end this class, so we're just gonna continue on this question, the ratio question. So I just wanted to, thank you guys for coming in. I know this is now, or the couple of weeks has been very difficult, especially the school closures, but I hope this inspires you to structure your routine, attend my classes, and also if you do have any friends who might be interested in joining our classes together, you can check out my schedule on oneclass.com/livestream. So this is where I have my daily schedule. So I not only host Q&A sessions, right? So this is where my daily schedule would be found. I do teach other math classes, so make sure to check that out. And we also have a lot of talented educators who are teaching on this platform. So yeah, just feel free to check it out. And thank you so much for watching and happy Friday. Bye, guys.